All right, I was able to kick them out, so now it might feel a little bit more quiet. By the way, I'm pretty sure Mr. Race is the loudest out of all of us, but let's not tell him that. Okay, so now we're going to do toolpaths. If you have a drill hole, then you'll want to do this toolpath. If not, if you don't have a hole to drill, then you can literally just kind of skip ahead. So we're going to go ahead and we're going to click on this little button here. It's a drilling operation. And then we're going to go and we're going to select a tool. We're going to make sure that we're picking from our 2025 Haas tool library. And we're going to pick tool number 11. Don't pick tool 10, pick tool 11 and select it. We're going to go to the third tab for geometry. Hole faces should already be selected. And then you're going to hover over the 1/8 inch hole and you're going to pick it. Then you're going to jump to the fourth tab called heights, and you're going to change the offset to -0.05. Then you're going to go to the cycle, and you're going to change the cycle type to deep drilling and full retract. At that point, you're going to click OK. Take a minute to right-click and preview or your simulation and watch it. Make sure that it's what you want, which is just basically drilling and pecking. And then you can exit your simulation. From here, we're going to now pocket all of the holes or the pocketed areas of your keychain. So we're going to go up to 3D, make sure you're on 3D, and we're going to pick the first option, which is adaptive clearing. You're going to go to your tool and select tool number 3, the flat end mill, the 1/4 inch flat end mill, and you're going to select it. Jump directly to the geometry tab and change your machining boundary to selection. And then you're going to find any edge of your model that defines the perimeter. So for me, it's going to be this oval. If you did a circle, pick a circle. If you did an irregular shape, pick the edge of the model, like I'm doing here, until it lights up. Then we're going to go to the heights tab. And the only thing we're going to change is the bottom height to be offset to -0.05. That's just in case there's any through features that need to be punched out. For passes, you're going to turn off stock to leave, and you're just going to make sure that the roughing max step down, maximum roughing step down, is set to 0.625. Yes, I'm recording a video, and I've got some visitors here during my video. But no, welcome. You guys can come back, and we can chat. But you can say hi to my video while I'm... Say hi, guys. All right, good to see you. All right, I've always loved visitors during my videos. All right, so we're going to go to max roughing step down, and we're going to put in 0.625, and then we're going to go to the linking tab, which is the last tab, and then we're going to change our ramping angle to 8 degrees, and then our helical ramp diameter right here to 0.125. And then we're going to click OK. Give it a moment. And then you're going to see the preview of your toolpaths. Now would be a good time to right-click and simulate. You'll probably notice that there's some areas that didn't cut because maybe your tool didn't reach. For me, it's the inside area right here. So I'm going to exit my simulation. Because I was not able to fit my tool into this area, I'm going to do another 3D adaptive clearing. And I'm going to use a smaller tool to kind of fit into the area that I missed. So select. And this time we're going to use tool number 2, which is an 1/8 inch flat end mill. We're going to go to geometry. We're going to go to machining boundary, and we're going to pick selection. Same thing we did before. Pick the perimeter of your part, whatever shape that might be. Go to heights. Change the bottom height to the same -0.05. Go to Passes, turn off Stock to Leave, and for this one, we're going to change our maximum roughing step down to 0.125. And again, for your linking, make sure it's on helix, 8 degrees. And then for our helical ramp diameter, 0.05 is acceptable for this small tool. Hit OK. And as we watch it generate the toolpath, you'll notice that it's only going to cut the material that was missed by the previous operation. And you can, of course, preview that by simulating with a right click and watching how it only cuts that remaining little sliver of material that before was missed. Now let's do some tracing. In order to do your tracing, you have to have some two-dimensional geometry that's on the surface that you want it to be traced on. So if you have different levels, you want to make sure that you have multiple tracing operations on these different levels. So for me, I'm only going to trace on this surface, so I'll only have one tracing operation. If I had lines on the bottom surface here and on this surface, then I would have two tracing operations. So I'm going to go to 2D, and I'm going to pick Trace. Don't pick Engrave. Pick Trace. Select your tool. You're going to pick the engraving tool number 8. Select. For geometry, this is really simple. You're just going to pick every line that you want to include to be traced. Don't make any changes to the height. And under this Passes window, you're going to change your axial offset to negative 0.005. And that's how deep you're going to engrave things. The last tab, make sure lead in and lead out are turned off, unchecked, which they should be by default, but just in case, make sure, and then click OK. You can preview this to see how deep those grooves are being made as it traces along and engraves your text or your lines or whatever it is that you're engraving. Finally, we need to cut this out, and that's going to be a 2D contour. In order to do the contour, we're going to select our tool. We're going to use the 1/4 inch. Always use the 1/4 inch for contouring. We're going to go to the Geometry tab, and we're going to pick the perimeter of the part. When you pick the perimeter, make sure this red arrow is on the outside of your part. If it's on the inside, like you see here, click that red arrow and make sure it's on the outside. That shows which side of the line the tool is going to cut. Click Tabs. Change the tab shape to rectangle and change the height to 0.08. Go to Heights. Change the bottom height to stock bottom and change the offset to negative 0.05. Go to Passes, turn on multiple depths, and change your max roughing step to 0.15. Very important, so it doesn't go down too deep for any one single pass. And then in the very last linking window, you're going to want to make sure that you turn on ramp and you change the ramping angle to 8 degrees, very similar to the helical ramp, but this one's going to be a linear ramp as it walks its way around this perimeter that we've defined with our geometry. Once you're done with all of those settings, click OK. And that is the last step. You can see if I tilt it, the tabs, there's 2 tabs that are generated. If I highlight everything, you'll see all those toolpaths. And I can then simulate each of those toolpaths all as one. You can see the drill. You can see the roughing with the 1/4 inch as it misses that little bit in between the C. And then you can see the 1/8 inch, the engraving, and finally the contour. Once you have that, make sure you save. If you don't like what you see in the simulation, then you need to go back to your design. You need to make, oops, you need to go back to your design, make changes, and then go back to manufacture and then regenerate these by simply right-clicking on them and generating them again. And then the toolpaths will automatically fix themselves based on the new geometry or model that you fixed. Okay. You can also highlight all of your toolpaths and it'll give you an idea of how long your part's going to take. This is a 5-minute machining cycle. So that is it. Don't post your code. I want to check these before we actually post to the machine. But that is how to do all of your, what is this, five different toolpaths. Thanks for watching, and especially thanks to my coworkers for not interrupting me during this video. Have a great day, guys.